Okay, so this is the first lecture of practical machine learning. Throughout the whole semester, we're going to talk about bunch of concepts that is used in the practical machine learning and the various different models and the various different approach, and together with realistic data set, and all these case studies as well. So this is a very and a practical courses. You are going to work on practical data, and in the meantime, you are going to test and work on your practical data by yourself. So this is not just a demo for you. And you also has the opportunity to practice by yourself. Okay, so let's get started. And the first thing that you should look at that is the syllabus, and the syllabus in the bright spaces you should check out. I have my email, I have all these courses needed, all the homework project, all these kind of problems and the related. And if you then go through the syllabuses, and you will see all these important informations. And you will find out when we have a bunch of like home problems, and all these problems sets will have realistic data set, and some of the data set will be really, really large. And these large data set, and we're going to teach you how to approach and how to analyze these data set, and how to build the models on these large data sets. Okay, so machine learning. So machine learning in the industry. So this is very different in academia. So you probably have took some courses in our department. There are various different like flavor of machine learnings, and decades ago. So these machine learnings are mainly used by big tech companies like Google's, Microsoft's. But nowadays, it's very common for those small companies and other companies, even like daily use companies, to use machine learning to drive revenues. So this is being very, very popular, and nowadays has been used in various different sectors. For example, like automobile, for example, the self-driving and auto driving, all these kind of things is very, very popular. For example, Tesla is using all these kind of machine learning techniques to develop these auto drive and autopilot features. Manufacturing, so this has been very popular in the recent couple of years to use machine learning. So for example, to find a defect in the product, and also, for example, trying to find and find out what is the best and what is the efficient pipeline or flow in your manufacturing. Retail, finance, healthcare, they all being used a lot. For example, retail, if you are doing online retail, for example, Amazon, and there are a bunch of like recommender systems. We're going to talk about recommender system in this courses later on. For example, healthcare, you have a bunch of and test the result, and also each patient has their own features. For example, the age, their pre-existing conditions, and so on. This can help the physician to make the decision, and also to tell whether and what kind of diseases that patients have. So in fact, you are going to work on multiple datas, for example, in the retail, healthcare's, in your homeworks, right? So I'm going to provide these data for you. I'm going to provide some instructions and what we're looking at, right? So I will ask you to actually to work out all these problems and by yourself. Sometimes it will be guided. So that means I will tell you how to do this step by step. It's like I help a baby to walk. As I'm holding you to walk, as I tell you, you should do step 1, step 2, step 3. But gradually, I will let you to do it by yourself. So that means there will be no guidance at all. So eventually, so this just gives you some idea once you have to work on some big data set in your, so while you are in like real situation, you have like some datas. This gives you some guidance or guidelines or like and sufficient training for you to actually to tackle these kind of data set by yourself for those kind of realistic data set. And also COVID, and actually people will stay at home. It actually accelerate this process a lot. And you can see right now, this is the so like and from like and McKinsey's like report. I'm actually give you some idea about how this AI and adoptions from the previous years. So you can see it actually there will be and significant increases in various like and sectors, and for example, marketing and sales, all these kind of things, and also like service operations, and all these kind of like product service development, and all these kind of things. They are all heavily relied on probably like recommender systems. And a strategy cooperative finance, it's probably going to work on, and also like risk, and it's probably work on whether and that person or the company has a default like risk or not, and that this is becomes a binary classification problems and so on. So machine learning is actually providing those kind of powers on these various different sectors. And also like mention a little bit on this and applications. So this give you all these kind of things, for example, and the manufacturing, predictive maintenance, it's like give you some idea, like when will this like, and the line may like break down, all these kind of things, quality controls, whether, I mean, this product has defect or not, retail recommendations, or chatbot, very important nowadays, right? So for example, if you want to talk to like customer service in Amazon, it's probably the first layer will always be chatbot. Maybe like 10%, 20% of these things will be solved by chatbot, and rather than a like customer service or human being, this will save and like reduce some cost. Demand forecasting, and again like and recommendation systems, and related to and recommendation systems. So I mean, this is quite interesting, because think about like how this actually work. I mean, this is actually can give you some idea how this machine learning actually work. And for example, snow shovel, right? And in New York here, snow shovel is very useful during winter. So, and if you like online retailer, you should start to stock this kind of snow shovel during like in the fall or like during winter. However, I mean that doesn't make any sense to stock those kind of snow shovel during summer seasons. So basically, all these summer seasons, I'm not going to stock those kind of snow shovels. So this is kind of demand forecasting, right? So, and then there will be and a periodic demand forecasting based on the histories of like snow shovels. And of course, this gives you some predictions how much you should start to stock, maybe starting the an autumn, and give you some idea how much you should start and to stock those kind of product. Healthcare, and you can have like some real-time patient data, and this is like an extremely helpful. For example, like and some patient have like some data collected from and from like and their medical equipment, and the AI can immediately analyze these data to tell whether this patient is in danger or not. And if patient is in danger, they can immediately send to the physicians, and a physician or nurse can come to see the patient. So this is very important. So, and rather than, like wait for nurse to come, this real time and response could help patient and could help like nurse and a physician to quickly judge the situation for the patient, and rather than to look at this patient all the time. Disease identification, I have talked a little bit here, and in fact, in your homeworks, you are going to work on some of the disease identification problems. Fraud detection, maybe you're going to work some related problem as well to detect whether this transaction has the fraud and risk or not. Automobile, self-driving, autopilot, all these kind of stuff. All right, so this is a very important, and also as I'm missing out, one of the important thing is house sale predictions. So this is very important, and case studies. In fact, we are going to work on this case studies very thoroughly from different angles, and you are going to work on some realistic data set in this courses. So this is house sale predictions, and the goal is to predict the bid price for this winning buyers. So what does that mean? And this is like, say, the snapshot for like Zillow, and this is the like Zillow estimated prices, right? So this is $3.4 million. The actual sold is $3.395 million. So, and you can see this is very, very close. And actually the ask price is $3.3 million. So you want to using these kind of various informations, all these like housing informations, to make a predictions for these houses and for the bid prices for these winning buyers, right? So, and this is being very, very important. So basically this will be your target, and this will be your estimate. And you can see if we actually estimate this value, and this is my target, you can see this is doing very good job. So you can see they are really, really close to each other's. So what we are going to do, if we want to work that specific problems to predict the bidding price for the winning buyer, so this is actually a workflow, right? So this is very important. In practice, your boss is going to give you a problem. You have some data, you have some problems. You actually need to formulate everything into this kind of machine learning workflow. Okay, so all these practical machine learning problems, you need to work out these kind of workflows. So the first thing that you need to do is you need to formulate the problems, right? So, and then my problem is I want to predict house sales prices. So what shall we do? If this is our task, the first thing that we should do is we need to collect and process the data. So that means I'm going to collect past house sales record to extract features for those past record. So basically, and for example, say this is one of the features that we have. Well, this is one of the data that we have. So that means we can have the data for the ask price. We can have how large of this houses, which is an 8,873 square feet. And we have a city, which is Colorado, and it's in the California, and we have a zip code as well. We have a lot of informations about these houses, okay, before we make any predictions. So this is basically the target price and the target we want to make the predictions. So you can train an intuitive model to fit these target values. For example, you can train a simple linear regressions to that. And also you can deploy your models and to predict the future sales. For example, if you have a new data, the entry is coming in, and you can using your models to make a predictions to this this and a bidding price for the winning buyers. So then you can deploy these models. And then later on, and you need to collect more data. Then you can keep training your models and update your parameters. It actually is very important because and your parameter may gradually changes, right? So this is not something that is always 100% constant. You have to monitor the accuracy changes with the models. And you might have some model biases as well. You need to fine-tuning these models along the time once you have more and more data. So this is very important. You are not just sitting there using your old models to predict everything else in the future. In fact, you are also gradually fine-tuning these models and monitoring the accuracies for those models. So, and this is very important. So this is, and actually give you a cycles here. There are a bunch of things and work on that. In this courses, we're going to go through each of this. In a lot of cases, we are going to work on how to train and tuning models, right? So this is the key of this whole courses, but also we are going to work on how to formulate these problems. Formulation of the problem is also extremely important. Okay, so this is basically some challenges in a machine learning stage. So as I said, we need to formulate problems. We need to focus the most impactful for like industrial problems. Not all the problems is suitable for machine learning. Some may be really suitable, some may not. This house price prediction, house sales predictions is a very typical, is a very good problems that we can actually formulate this and using the machine learning and using machine to actually help to make this and predictions. And also data. Here we said we need to collect and process the data. This is very important because high quality data is very rare, very scarce. So that means and a lot of time what you are going to get the data is very noisy. For example, you can scrape the data from Zillow, you can and scrape data from Raffing and so on. But those data and USC is really noisy, really messy. You actually need to clean that and the data. Cleaning the data is very important. And also you cannot scrape data and forever because it might have some privacy issues. Not all the public domains allow you to scrape the data. All right, so and also you can train the models. And your like machine learning models getting more and more complicated. You can do like neural networks. You can do very complicated neural networks. It's very expensive to train the models nowadays. You can even using like large language models to help you. And they are also very data hungry. So you have to worry about one other thing is training. Training could takes a really long time here. And also, so we are actually focusing on these trainings and how to formulate a problem, how to get the data, how to train the models. So these three things is being well discussed in these courses. For the next two, they are not discussed in these courses. However, it is really important in practical part. For example, you actually need to deploy the models, right? So once you have your models, you need to deploy that. If you want to, if your model is involve very heavy computations, it might not be very suitable for real-time inferences. So think about one way is you want to give recommendations to those like Amazon buyers. And once you click one link in Amazon, it will have a bunch of like recommendations for those kind of like related to the searches. Usually this will only take about 0.1 seconds, right? Within 0.1 second, the customer or the buyer will expect Amazon to give some feedback, right? So, and give me some recommendations based on the algorithm Amazon has. However, if I have to wait more than 1 second or more than like 2 seconds for this response, the customers may lose the patient. So that's why if you want to deploy some models on these kind of recommender systems, if it involves some heavy computations, it might not be suitable if you want to do like real-time feedbacks. And also, you also need to worry about like the monitoring, as I said right here, because gradually this data distributions may shift. Think about the way, the example that I give, which is the snow shovel sales along the seasons, right? So it might start to like shift along the time. You cannot, it doesn't make any sense to stock the same amount of snow shovels through the whole season. It doesn't make any sense to do that in summer. So that means these kind of data distributions will shift along the time. And sometimes they also have fairness issues. Okay, so this courses, the key is we are going to do these 3 things, top 3 things. However, I'm going to talk a little bit on and deploy models and monitorings. But this is really, once you're being a data scientist, you actually need to worry about that. So this is basically the techniques that data scientists need, but many times are not taught in universities, in many like machine learning statistic programming courses. We will cover a lot right here. However, there's still like a large portion will be missed out. So for example, in the data part, we're going to talk about how to collect the data, pre-process the data. And we're not going to talk too much about label shift. We're going to touch a little bit on a time series right here. So that's why it's important to understand something on the label shift and the shifts as well. And all these data, if it is beyond IID, that's something that we have to be and worry about as well. Models, we talk about model validations, combination tuning, transfer learning, and this is something being used in the convolution neural network. Multimodality, we're not going to talk about this. This is usually being taught in the computer science. And all these kind of like deploy and monitor. So, and these are, and as I'm only going to briefly touch and these 2 parts. We're going to focus on the data and the training in these courses. But however, all these techniques and are actually so data scientist needs, but usually not taught in machine learning courses. Okay, so what is a data scientist? What is like machine learning engineers? So this is actually give you some good idea what they are doing right here. Actually, people who work on data sciences, they have 4 different roles. The first one is domain experts. So this is basically has some like business insight, know exactly what data is important and where to find it, and identify the real impact of a machine learning models. So these are usually being think about as a like a leader, right? So they know the data is important. There's some, and you have some data, and you want to actually using the machine learning model to make the real impact for that. And then we have, and also this is basically has some business insight. Sometimes when people are working on data analyst and has some like these kind of like domain expert as well. Data scientist usually has a full stack of data mining, model training, and deployment. So basically, it has a full stack on front end and to the back end, right? So this is the like target jobs that we're looking at. And the machine learning experts. So this is slightly more evolved. So I mean, this target jobs will be machine learning engineers. So it's basically you have to customize these kind of soda, like these state-of-art, and like machine learning models. You are going to open those models and rewrite some packages and to suit your need and something like that. So this is usually actually, I mean, if you want to looking for machine learning engineers, you are actually and expect you to be like a PhD degrees. For data scientists, I would say most of them are like still welcoming and still welcome master degrees. But for machine learning engineers, this is mostly focused on and folks and mostly like and recruit PhD degrees. And for PhD students, they are able to like open those packages as will be and has the capabilities to rewrite some packages. And the third one is SDE, and SDE is like software and develop. So basically, is once you create these kind of like pipelines, and once you create those models, you actually and will tell the SDEs to develop and maintain these data pipelines. So basically, you're going to build the pipelines, and once you have a new data, and this pipeline will do these kind of training, and it will do these kind of inferences and so on. And also, this SDE will monitor these pipelines. If something is going wrong, or like something is wrong, it will try to fix that. That will including the model training and surveying pipelines, right? So basically, this is actually the person actually trying to monitor this pipelines of the data. So you have like data coming in from sales and how you process the data and what is the feedback, right? So this is something like that. Okay, so this is basically skill sets for 4 different roles. This is SDE, this is domain expert. And the domain expert is usually either leadership or data analyst. Right? And these two are not the focus of these courses. In fact, the focus of this courses is the role of the data scientist and a little bit like machine learning engineering. So because some of the tasks that I ask you to do will actually need to open the packages, need to rewrite the packages and so on. So this will be a little bit challenging. So this will be a little bit more like challenging than data scientist. But data scientist is actually the full stack, like from the back end to the front end, right? So this is also very hard. And also this is also a very important figure right here. You can see this is how data scientists actually spend their time. 19% they are doing like data loading. 26% is spent on data cleaning. And 21% spent is data visualization. Only 11% is on the model selection, and 12% is on the data model training, and the last 11% is deploying. So you can see the very important things is if we include this pre-processing and and cleaning data and processing and visualization of the data, this already take more than 50% of the time. That including data loading, data cleaning, and data visualization to understand the data. So you can see understanding the data is really, really important. Once you have the data is messy, data is big, data is complicated. You need to understand the data before you actually choose the right models. If you don't understand the data, you just blindfolded to choose the models in scikit-learn, I can guarantee 99% chances you are giving me the garbage. So the key to success of being a data scientist, the first things is you need to understand the data. Okay, you understand the data, you can do that through the data visualization, you can do like data cleaning. Then once you have a sufficient understanding of the data, you know how to approach the data. Then you can do model selection and the model trainings, right? It turns out these two already take about nearly 50% of your time. Okay, so in these courses, we're going to focusing on data cleaning, data visualization, model selections, and model trainings, all 4 parts. Okay, so the first thing that I want to talk about is how to get the data, right? So, so for example, if you want to work on some like ML, like machine learning applications, the first things to ask, do we have enough data? If we have enough data, then we'll move on to the next part. If we don't have, enough data, the question is, are there any external data sets that we can use? If we have some external public data set, we're going to discover and integrate this data set into the current data sets. If we don't even have this external data set, we're going to talk about how to approach this later. So the first thing, you need to discover what data is available. So that means if you need to find, so you actually need to find what is the existing data set. And then there are a bunch of like popular data set you can find. For example, this MNIST data set is being used a lot. And ImageNet, that's millions of images, right, from the search engines. Audio set, this is kind of sound clip from the YouTube for the sound classification. And this is like an speech from audiobook. That's like kinetics, which is like video clips, and so on. Like for example, Amazon reviews. This is like customer review and reviews from Amazon shopping. So these will be all these kind of like existing data sets. So these are popular and the data sets that you can find. But in the meantime, you can find other data sets. For example, and you can find the data set from paper with codes. These are an academic data set. Kaggle data set. This is like very large, and machine learning, and they have a lot of data set and uploaded by the data scientist. And a lot of time they have some competitions. You can work with the competitions as well. Google data set. This is like actually search the data set in the website. There's a bunch of tools and a data set. They have like Hugging Face has data set, TensorFlow has a data set, and so on. And sometimes they have company competitions in Kaggle. They also will provide some realistic data set. All right. So and also like open data in on AWS. From this, they are all like an open source data set. It's like you actually access and use freely. But sometimes if you are and work for the company, you can, and you have like private data set, you can have like data lakes, and you can work on those data sets for your own company. It's very important that you need to find the right data set, these like benchmark data set to evaluate these new ideas. This is very important because if you have a new idea, you want to find the right data set to evaluate, to check your new algorithms. For example, if you want to work on like new hyperparameter tuning algorithms, you can try a diverse set of small to medium data set, which you don't actually need to use a very large data set. If you have want to do a very big deep neural network, you probably want to work on large scale data set. So this is something that depends your need. You actually need to find a different scale of the data and the data set. It's very important that you only and you understand the data, you understand what kind of problem you are like approach, and then you find out the right and the right data set to work with. All right, so but these data set is actually quite tricky because you think about and there's some like raw data in the industrial settings, so like realistic data, and also something like in the data like curations. It could be a big like projection involving multiple teams, and have processing time, pipeline, storage, legal issue, and like privacy. There are a lot of issues. Particularly if you want to work on the realistic data set. And in the realistic data set, and these raw data, it actually needs a lot of effort to process. So this is something we are going to teach you how to pre-process this data. What is the right way to process these data? How to using various different techniques to understand and these data sets. But like the benefit to using these kind of realistic data set has great flexibility. So this is real data. And this, I mean, but this is usually a very large like data set, very complicated. But if we compare, we can do like competition data set. It's pretty close to real machine learning applications, but still quite simplified. And those competition data set only available for hot topics, right? So if you want to work on very specific problems, they might not have competition data set. If you just happen to want to work on some very interesting problems, those hot topics, these competition data set is very good. I mean, in fact, could and actually help you to do a lot of interesting problems. Academic data set, which is some like Amnesty data set, it's very clean, it's very balanced, has proper difficulties. So that means not very difficult. But those kind of academic data set has very limited choices, very simplified, usually very small scales. Think about this MNIST data set. Each image is 28 by 28, right? So this is a super, super tiny images. And this MNIST data set only have 60,000 images, which is tiny compared to nowadays. We have millions of images in the ImageNet, right? And the pixels in the ImageNet is much and bigger. MNIST data set only have 28 by 28. All right, let's see what we have. Okay, so, and also you need to understand how to do this kind of data integration. The data integration is you want to combine the data from multiple sources into one coherent data set, right? So you have like different sources. You have like sources from your own and data set. You have some sources from public data set. So what you can do is you can like product like data is stored in like it's often stored in like multiple tables. For example, one table is of house information, one table is house of sales, one table is house and for the listing agent. For example, this is table 1 and this is table 2. And you can see we have the first data entry, we have a second data entries. However, on table 2, we only have a first data entries, third data entries, then fourth data entries. So what you can do is you can do inner join. So that means we're going to find the common data, right? And we're going to join them together. So that means what the join of this like table 1, table 2, that means we only have one data entries, right? And which is entry 1, that I'm going to join with the blue and join with the red, right? So this is basically the things that we can work with. And and obviously that means we're going to throw out a lot of rows and a lot of data. So what we can do is you can think about, okay, maybe like left join. So that means I'm going to include everything for this table 1, but in the meantime, I'm going to include everything that we have for the table 2. But for the second entry, we don't have any information from table 2. I would leave as missings, right? So then we have some missing and data right here. So this is also very commonly used. Sometimes we can take a union for that. We are going to include 1, 2, 3, 4, but leave everything that is not included for like either of tables to be missing data, right? So just treat everything that we don't know as a missing data. So this is the way that we can do like data integrations, right? So this is important, and because once we have those information, we want to fully use of them. This is like generate data. So this is, we don't want to talk too much about this. The only thing that we want to talk about this is data and data augmentation, and particularly for this image augmentation. We're going to talk about this in the deep learnings. In fact, this is very important because in a lot of cases, if you have only one images or like very few images, if you want to train your models, we usually don't have enough images. And how can we do that? We can do some augmentation. That means we're going to rotate this image. And once we rotate this image, for example, this image is a cat. Once we rotate this image, I'm still a cat. If I flip the image, this is still a cat. If we turn the like color image into a black-white images, it is still a cat. So we can manipulate this one single images by doing rotations, by doing truncations, by doing like cropping, by doing enlarging, by doing flippings, by manipulating the pixels. Then you can see this is basically an augmentations of one single images with various different treatment of these augmentations, right? So this is very important. So that means we can significantly enlarge the current data sets if we only have very limited data. Okay, so this is very important. Once we have that kind of thing, then we can use and put this as our, to our training data, and to train our models. Because if we do these kind of augmentations, presumably it is still a cat. Okay, the next is data labeling, right? So this is once we have a data, and if we don't have data, then we already cover that. If we have, like, say, enough data, I'm going to add the labels, right? Very important because, and a lot of time we're trying to do some supervised learning, for example, to distinguish the cats versus dogs. If we have the data, we are going to work on the data pre-processing. So this will be covered in the next later lectures. If we don't, we're going to create the labels. So the question is, do we have enough labels to start with? If we have, enough labels, we can using semi-supervised learning, SSL. If we don't have enough labels, so we have two possibilities. Do we have enough budgets? Right. So if we have enough budget, we can label that with crowdsourcing. So basically, we can pay someone to label it for me. Right. So this is quite expensive sometimes. If we don't have enough budget, we can maybe using weak labels if possible. For example, one of the weak labels is we can using large language models nowadays, right? So we can using ChatGPT, we can using Clip, we can using like BART, all these kind of and a generative AI to create the labels for you. So these labels, it's not a precise labels, it's like weak labels, right? So this is not precise. And we can using some like weak supervised learnings as well, if possible. But of course, this is not always the best choice and the best situations. This is the compromise with not enough budgets. So say we have some label data. So what we can do is we can apply something called semi-supervised learning. So this is extremely important because this actually has been studied and used a lot in practice. So so think about you have a scenario that there is some small amount of like label data, and it's still I'm going to using the examples of cats and dogs, right? Say you have like 10,000 images of cats and dogs. Out of 10,000, like 1,000 and images, which is a small amount of the data, are labeled. Okay, with a large amount, like 9,000 images being unlabeled. So what we can do is we can make assumptions on like data distributions to use unlabeled data. For examples, continuity assumptions. That means the examples with similar features are more likely to have the same label, which is makes perfect sense. So that means that we can, if they, these two images is close and enough, maybe we can assume they have the same labels. Clusters assumptions, that means this data may have some cluster structures. That means there's a one cluster being cats, one cluster is being dogs. That examples in the same cluster tend to have the same labels, which naturally means that we can do some maybe clustering algorithm on that. And the manifold assumptions. So that means we all know images has like a lot of pixels that actually lives in very high dimensions. But usually those images may lie on the manifold, has much lower dimensions than the input spaces of the pixels. And what we can do, I'm going to talk about two different ways of SSL. The first thing is self-training. So self-training is one method of semi-supervised learning. So say we have some labeled data. Well, with this like small amount of labeled data, we're going to train some models. And for example, like random forest. Okay, so then what we're going to do is we have a large amount unlabeled data. So that I'm going to using this unlabeled data to make the predictions, right? So this is when we make these predictions, I will create like pseudo labeled data. So those models can tell me which one is dog, which one is cat, and so on. But I'm only going to keep highly confident predictions, right? So I would say 99 and 95% confidence I predict these images to be cats. I'm going to keep these labels. Then I'm going to merge this into my label data and update my trainings. So this becomes a loop. Right, so this is gradually trying to enforce our models and to make sure this is models get to know this like cats and dogs more and more new cats and more dog and new dogs, and gradually reach their knowledge and hypothetically can make our models better. And of course we can use very expensive models here because it has more power to predict, to make the predictions, and it's more complicated and it has a bigger powers to make the predictions on those kind of complicated problems. And for example, this is like deep neural network or like ensemble methods, like deep learning stuff, right? Okay, so but this is not very helpful sometimes because like what about those kind of like low confidence predictions? And sometimes I may like encounter some like error as well, right? And how do we handle that? So what we can do is like this SSL, but sometimes we can contribute with the humans, right? So and human is also included in this situation. This self-learning is basically helps propagate the labels to those unlabeled data. But we can do some like active learning. So basically the model select the most interesting data for labels. So what does that mean is like, say, this is a model, but this model cannot make the predictions. Like say, okay, I don't know what's going on here. I mean, I only have like 55% of confidence to say this is cats. So that means I have very low confidence for that model. So I'm going to grab that images and using human knowledge to predict whether it's a cat or dog. Right. So then I'm going to say, okay, this is cats by human being. So this is a true label. I'm going to put in back into this and the label data and reinforce our models. Okay. So this is called active learning. And also like an uncertainty sampling. For example, I'm going to select those samples whose predictions are most uncertain. So that means I'm saying like 50 or 55%. And the highest class prediction score is close to like uniformly random. If this is uniformly random, that means basically this model is not making any good predictions. And also we can like doing like ensemble ideas. That means going to train multiple models and select examples that models disagree and is with. So that means these are the examples are kind of like complicated in some senses. So this is something, these examples are very interesting. So that means I'm going to pick out those examples and actually trained by human beings. So in fact, this models is really can combine them together for this active learning and self-learning part. So everything here is being the same. The step 1, step 2, step 3, step and step 1, step 2 the same. But on the step 3 is I'm going to separate this prediction into 2. One is the most confident one, like 95-90% confident this is a cats. That I'm going to call this is pseudo label data. I'm going to merge back into label data. However, I'm saying like 50%, 55%. That means I'm not very confident. These models are like less confident, or maybe they have a conflict with the different models, right? For example, random forest predict it's a cat, and the logistic regression predict it's a dog. So that means they don't agree with. So these images will be like labeled by the human beings, right? So the human beings will say, okay, this is the cat. Then I'm going to put that into the label data. Okay, so this actually is going to using human beings to actually to increase the domain of the knowledge gradually and a little bit. For those simple cases, is being like labeled by the and by the machine, by AI. For those like difficult cases, it will be labeled by the human beings. So instead of using crowdsourcing from the first, which could be expensive, we're only using those crowd and human label and labelers just like for those very specific difficult cases. So this can significantly reduce the cost of the crowdsourcing. So this actually help for those kind of like and budget issues. Right? So this is very helpful. So this give you some idea in practice what kind and how do you approach these kind of problems. In fact, these are all commonly asked questions during interviews. If you actually being asked, I mean, during a data science interviews, if you have the problem, say we don't have enough data, how we approach that, right? And say if we don't have enough label data, we only have very limited label data. How can we approach that? Okay, so these are all commonly asked questions during data science interviews. All right, so that's everything I want to talk about today. This is the first lecture. In the next lecture, we are going to do a simple case study. So give you some idea how to approach that, give you like whole picture of what and what we are doing in this courses and what you will experience in this whole semester. All right, so that's it for now.